Good evening, folks, and welcome to a very special Night at the Observatory Q and A session. We get lots and lots of questions from you, the audience, when we're doing our Night at the Observatory streaming, and we thought we'd take a few of those that we weren't able to answer during the stream and give you a bit more of a detailed answer. We also decided that we'd make this a Christmas Eve special, something that we could share with you as a little Christmas present. Andrew and I answered a few questions, and so we're going to start with Andrew answering some questions about Saturn.
Evening, everyone. Andrew here, and here are some answers to questions I received. During our third night at the observatory, there were a few questions I didn't have time to answer. This first one was from Maria Walsh. Thanks, Maria. Maria asked, Andrew, can you explain what you mean by slingshot? Well, when the Voyager spacecraft set off back in 1977, I think it was. Yes, on their grand tour, number 2 was launched first, and then Voyager 1, even though it got there first. Their launch was timed to coincide with an extraordinary alignment of the planets in the solar system. Earth was in a position where a spacecraft could use the gravity of planets further out to reach its destination. This enabled engineers to use the gravity of each planet visited to accelerate the speed of the probe and divert its course towards the next planet in the solar system. This was often referred to as a slingshot. And in this video, you can see Voyager 2 was launched first, and first it headed out and caught up with the orbit of Mars, not as close as it would get to other planets, but the effect was enough to change the course slightly and to accelerate it slightly as it headed away. At this point, Voyager 1, because of where it was launched from, was actually catching up and passing Voyager 2, and as it became closer and closer to the orbit of Jupiter, you could see that it was going to get to Jupiter first because it got to Jupiter earlier in its orbit around the Sun. As it arrives in Jupiter, you'll see that it comes very close, and this bends the course of the craft, there it is, and also accelerates it. It virtually falls into Jupiter and then accelerates away. Same with Voyager 2, which encountered it a short time later. And then both of them headed on to Saturn. After hitting Saturn, Voyager 1 headed off into the outer space and is still going. Voyager 2 continued on until it reached, there it is, Uranus, or Uranus as you prefer, and then it slingshotted on to Neptune, and then it initially was to head out into, yes it did, it headed out into the other side of the solar system.
All right, it's my turn. Andrew Hayes asks, would love to learn more about getting into astrophotography on a super tight budget. Well, I've got good news for you, Andrew. If you already own a digital SLR or mirrorless camera that was released in the last 5 years or so, and you have a tripod, then you've got all you need to get started in astrophotography. A digital SLR is a very capable instrument and can do amazing things with low light during long exposures. The photos you can see here on screen were all taken by me with a digital SLR and tripod. Having a good camera does help a lot. Having great lenses helps even more. But if you're on a tight budget, then you could perhaps start with a Canon or equivalent 50mm f1.8 lens. Because of the aperture, the f1.8, that makes it very fast, and so you can collect a lot of light. Shorter exposure times means less trailing, because of the motion of the stars creates star trails. The 50mm focal length lets you zoom in a little bit on some of the things like the Milky Way galaxy or the Southern Cross. The best way to get started is to practice a lot and forget about the technical side of things and just experiment and enjoy the creativity of it. To get you started though, The best settings to start with are often around about 30-second exposure time, the widest aperture that your lens is capable of doing, and an ISO of around about 800 to 1600. If you've got a newer or more capable camera, you can push that even to 3200 or even 6400 ISO. I'd stay away from the lowest or the highest settings of your camera's ISO, however, as that is where the camera starts to make adjustments to the amount of processing that it does in the body of the camera, and that's not ideal. The trickiest part is getting focus. The easiest way to do that is to put your camera into manual focus, point it to a bright object in the sky, whether it's a planet, the moon, or a bright star, and turn on the live view focus. Punch in the zoom on the back of the camera to 5 or 10 times and center the objects that you're trying to focus on in the middle of the frame. Then adjust the focusing ring on the lens until you can see the object that you're trying to image, you're trying to focus on, become as small and sharp as possible. You might need to move the ring inside or outside of focus just to be sure that you're getting it as small and as sharp as possible. But once you've done that, you can be pretty confident that you're in focus. Take a shot and then zoom in on the resulting photo on the back of the camera to check how sharp it is. If the stars look like little pinpoints, especially the fainter ones, then you're in focus. If they look like little balls or little elongated capsule shapes, that means you're out of focus and you may have some star trails going on. If you've got star trailing, it doesn't matter too much if it's short. When you zoom in 100%, you'll see it, but when you see the whole photo, you won't. However, if they're a bit too long, then you'll need to shorten your exposure time. That can be a bit of an issue because you won't get as much light in as you want, but it's a matter of choosing between how much light you want to get in your photo and how long you want the star trails to be. This is a good place to get started. There's lots of different variations you can do on this and equipment you can buy to get around some of the limitations. But with a basic digital SLR and a tripod, you can still take amazing photos. This, for example, is a photo I took 8 or 9 years ago with a Canon 350D, a very old camera, and the Canon 50mm f1.8 lens. And with this old equipment, I still managed to get a nice looking shot. The most important thing, however, is to get out under dark skies. Get away from light pollution. That will improve your photos more than anything else that you do, more than buying a better camera or a better lens. If you can keep away from the light that's being spewed into the night sky by all the city lights and cars and so forth, you will find you'll get much, much better results. You'll get cleaner images, higher contrast, more stars. So get away from the city, 2 hours drive if possible, and that will give you the best possible chance of getting great photos. I wish you luck and clear skies.
Now, the second question I got was from Melissa Ackhurst. Thanks, Melissa. And her question is, any idea on what caused the rings to happen? Well, there are two main theories about how the rings formed. One, the first one says that there was a moon in orbit around the planet, very close to the planet, closer than the other moons, and the tidal forces exerted by the second heaviest planet in the solar system tore it apart and spread them out over the rings and to become the rings. It's possible that there may have been a collision with a comet or an asteroid that was brought in by Saturn's gravity, and that triggered a broader distribution of the particles that the moon used to be made of. The other one says that as the planet itself formed from an accretion disk, the same material as was used to form the planet also formed the rings. Because of the tidal forces again in this zone, it was not possible for an actual moon to form, and the rings maintained the shape that we see today. There is another ring further out, the E ring, and it's visible only in images where the sun is behind the planet. And that one is quite different. That's formed more recently and continues to be formed by water from geysers on Enceladus just going around. So that will continue.
Next, we have a question from Savvy, age 15. Is it possible for a solar system to have two suns? The short answer is yes. But first, a little bit of trivia for you. Solar is a word that we use to describe the sun. It actually comes from the Latin name for the sun, Sol, S-O-L. So things that relate to Sol are solar. That means that if we're talking about other star systems, they're not solar systems because they don't have our sun in them. So it would be more accurate to call them star systems, but it's a shorthand to call solar system because that's what we're used to already. Anyway, that little aside behind us, the more that we look at stars around the galaxy, the more that we're starting to learn that binary or multiple star systems are actually the majority. The fact that we have a single star in our solar system is relatively unusual. More and more stars that we look at actually contain two or more suns, two or more stars. So it is absolutely possible, and in fact, very common for there to be more than one star in a star system.
The final question I received was from Chanel Joy. Thanks, Chanel. So just to specify, does the planet rotate inside the rings, or does the planet and rings rotate together as one, or do the rings rotate around the planet? Well, the planet itself actually rotates very rapidly. It only takes 10.5 hours for a day on Saturn. But every ringlet in the rings takes a different time to go around the planet. Every ring moves relative to the others, so they're not moving together. Probably the nearer ones are moving faster and the outer ones are going slower. To complicate that, there's also small moons or moonlets within the rings, which you can see a picture of there on the left, which are sweeping out gaps or rearranging the particles with the effects of their gravity. Not only that, scientists have noted that material from the rings is steadily being sucked into the planet and that they could disappear in as little as 1 million years. So thank you for those questions. Enjoyed answering them very much. I hope we answered them.
And finally, I have a question from Jim Pyohota. Has SpaceX had a successful flight? Yes, in fact, SpaceX has had many successful launches. In the year 2020, they have launched more rocket missions than any other group, including NASA. The majority of these launches are of the successful Falcon 9 rocket. Most of the launches have been of their own Starlink satellites, but they've also sold rideshare launches or solo launches to other companies to put their satellites into orbit. NASA and the United States military have also launched some satellites with the Falcon 9 or its cousin, the Falcon Heavy, a heavy lift booster that carries more weight into orbit. The vast majority of these have actually seen the first stage return back to Earth, land, be refurbished and used on additional rocket launches. In fact, the most successful booster has seen 6 successful launches and returns to Earth. So SpaceX is doing very well in their commercial efforts to make space access cheaper and easier for everyone, but their newly designed Starship prototype is taking a big step forward to making that even more accessible. So you've seen recently the test flight of the first SpaceX Starship prototype that flew to 12.5 kilometers but crashed on landing. However, they still learned an awful lot from that mission, and they succeeded in achieving more of the goals than they expected from that test. In the new year, we should look forward to seeing a new Starship prototype launch, and hopefully they'll stick the landing this time. In the next 2 or 3 years, we should see some very exciting developments with Starship, and hopefully return to the moon and soon onto Mars.
Ho, ho, ho. Merry Christmas, everyone, and a Happy New Year. And hopefully we'll see you at another night at the observatory in 2021. See ya.
Well, thank you everyone for joining us for our special Christmas Eve Q&A session. If you enjoyed this, please make sure you let us know in the comments below, and we might try and make a series out of this. It's a bit of extra work for us, but we know that you love having your questions answered, and we just can't get to them all during our live streams. We at MBO would like to wish you all a very happy holiday season, full of love, joy, and health. We look forward to seeing you in the new year, and hopefully 2021 will be a much better year than 2020 was. Happy days and clear skies to you all. Good night.